homological stability. Okay. Is it working? Is it not working? Let's see. There's okay. I need a few minutes to figure out what's wrong with my tablet. Sorry about that. In the meantime, Chris, if you want to announce something, please do, or entertain the public in any other way.
So I don't know what you were going to do. You were going to give an introduction to the idea of homological stability?
Well, a very short introduction, and then I was I'm planning to start talking about the Madsen-Weiss theorem without any further ado. Okay. Well, I don't really have any philosophical things to say about homological stability. So the idea is to get technical as soon as possible.
Okay, well, you fuss with your tablet. I guess what I would ask is to know the background and interests of people. I can just go down the list. Zhurbinka.
I don't think he's here.
No? Tarayan I know, but he can say something about himself. So, Grigory, what is your interest in this subject? What would you like to learn?
Well, I guess I don't have a lot of experience with homological stability and stuff like that, but I would like to learn some concrete things about like moduli calculus maybe and something like that. If this is an appropriate place to ask for such a thing, I don't know.
So I don't know myself about relations between Goodwillie calculus and homological stability, but maybe there is in higher dimensions. So we'll see. If you can come up with some references, we can take a look at them.
Okay,
Mark,
sure.
Mark Alexeyev.
Yeah, I'm here. I can't say much about
what you work on. What is your interest?
I'm working on singularity theory and equivalent topology. Do I need to explain about my work? Or
No, that's enough. And who is your advisor?
Maxim Eduardovich Kazaran.
And at which level are you? Which program are you in?
Sorry, what do you mean?
Are you an undergraduate, a master's student, a aspirant?
Yeah, I'm aspirant of first year.
Okay. Saman, are you there?
Yes, I am. I'm not sure if my microphone is good. I mean, do you hear me, Bill?
I hear you, yeah.
Yeah. When I read the introduction, it was written it's going to be about mapping class groups. So, I mean, my main interest is to understand them better because they're kind of related to three-dimensional geometry. So I mean, my goal is maybe it provides a way to understand them better for three-dimensional topology.
So indeed, the kind of big theorem, the big interesting theorem, is about homological stability for mapping class groups of surfaces. And you need to know something about these mapping class groups to prove it. So
yeah.
But if you're interested in kind of very specific things about the mapping class groups and their geometry, there are books about this. The popular one seems to be by Brav and Margaret. So that might be a useful reference for us if we need something about the geometry of mapping class groups. And so one thing we'll need, so I think I kind of looked at, we have some goal to prove this Madsen-Weiss theorem, which Alexey is going to describe. But it seems actually that the hard part of this is simply the homological stability of mapping class groups. And for this, you need some kind of good models for the classifying space. So we can look into how to do that. It might interest you. How about Smoodigan?
Yes, hello. So I have no idea about the context, the contents of this course. So I just wanted to see what's what, and then maybe decide if I'm interested or not. So I can tell something about what I'm doing right now, if you're interested.
Maybe it's okay for now. What about? Are you ready, Alexey?
Yes, just in case the tablet's working now.
Okay.
So
well, we had one more student. Let's see who he is. Vladimir Shane.
It's Vladimir, and there's also Dmitry Zhurbenko, who's arrived.
Okay.
Okay, Vladimir.
Well, Alexey, if you already know these people, we can proceed.
Well, let's. Well, we're not in a hurry. Let's talk to the remaining two participants. Vladimir Shane. Why did you decide to come to this seminar?
Hello, I don't know much about topology of moduli spaces. I think I just want to learn something about homological stability and related things. I'm not quite sure.
And
if
who's your advisor? Is it Vadim?
I'm sorry.
Who's your supervisor? Is it Vadim?
My advisor is Volогодsky Vadim.
And what are you working on at the moment?
Well, I'm mostly working in algebraic geometry. In the moment, I'm working in things related with prismatization.
Well, there is some relation homological stability to algebraic geometry. So we'll probably need to mention that. Okay. Well, Dima, could you please say a few words about why exactly you're interested in this seminar?
Actually, I don't have any specific ideas. I would go along with anything. So.
Okay, so well, I am Dima's supervisor. Dima is a PhD student, and he's working on moduli spaces of complex curves, and more precisely on Dima, what are you working on?
On rational homotopy theory of moduli spaces of curves of genus 1 and 0.
Okay, so in this seminar we'll be mainly talking about homology, cohomology, but there's also more complicated invariants such as the rational homotopy type and well, one of the questions one could ask about moduli spaces is what their rational homotopy type is, and that's what Dima is working on. Okay, so the name of the seminar is Homological Stability and Moduli Spaces, and the organizers are Chris Brav and Alexey Gorinov. I'll put the email addresses of their well, people probably know my address. Chris, which one of your addresses should I put?
Not HSE, because I can't log into that anymore.
So which one?
It doesn't matter. Whichever one you see.
Okay, so well, there's one. There's just one that I remember. Okay. It's chris.i.brav@gmail.com.
Yeah, that's fine.
So if you have any questions, please email Chris or myself or both. Okay, now let's get the technical points out of the way. What do you need to do to get a mark for the seminar? You need to give a talk and prepare notes in LaTeX, and well, each of the components is worth 50% of the mark. I would like to emphasize that the notes should be in LaTeX, and in particular, there shouldn't be just handwritten notes prepared at the last moment.
Maybe we can set up a project in Overleaf so we have the same style for all nodes, and then we can publish that.
Well, there's nothing wrong with that, but it's not absolutely necessary. Okay. Okay. Now,
if someone wants to organize that, that's fine. For instance, if Grisha wants to organize that, we will be grateful.
Okay. I see.
well, later today I'll mention a few topics, and there'll be more as we go along. Now.
Извините, Алексей Геннадьевич, можно вас по-русски спросить? Еще раз, что вторая часть значит? Вот эти вторые 50%.
Значит, вторая часть — это записки в латехе. Значит, записки именно в латехе, они написаны другим коленкой.
записки вот этого доклада.
Да.
Спасибо.
Well, there's one more thing we need to take care of. There'll be at least one participant who will not normally be able to come to the seminar. This is Chris. Chris doesn't live in Moscow, so he will not. Well, he may come in person once or twice, but normally he won't be able to. So, and by the way, there are other people who also can't come in person for various reasons. So, but still, we would like them to participate. And more precisely to participate in real time, to ask questions and so on, and so we need to we need to do something. This won't happen automatically. So there are several options. Option one would be to do what Lando and Kazarian do in their seminars. They have online participants, offline participants, and everyone asks questions, and it all works seamlessly or almost. But and it's not it's not a massively difficult thing to do, but still I have no idea how exactly it works. So if we go if we take this option, we need a volunteer. Namely, someone who would ask Lando and Kazarian what exactly they do, so that everything works, and then try to reproduce this success story. So, are there any volunteers?
Something like this without asking them. But, no.
Okay, so well, thank you very much. So we have a volunteer. Let's well. So next week, let's try to do the seminar offline in the math department, but with the possibility for online participants to really participate and not just watch the recording afterwards. As far as I remember, the room number is 208. And we start at 4:20, and I don't remember exactly when we need to finish. Well, anyway, it's in the timetable. Okay, so next week. next week we try to meet in person and we see if it works, and if it does, we'll just continue to have both online and offline people who, at least in theory, will be able to interact with each other in real time. Oh, that's the plan. Is there anything else we need to talk about before we move on to math? Are there any objections, alternatives, and so on?
Oh, I'm sorry to say that, but as a member of the student council, I know from the maths department administration that, at least according to them, there are no completely working sets of video recording like stuff for anywhere on the maths department. So maybe it will work, but according to my experience, hybrid format rarely works. But what do I know?
What about this big room upstairs? That's the one that Lando and Kazarian use. We can also ask Kalaydin, because I think they do something online with the seminars.
Well, if it doesn't work, then we basically will need to decide whether we carry on online as we are as at the moment, or we could which is better than just posting recordings on the website, because I would want people to ask questions. It's basically one of the perks of having a seminar rather than trying to read a book or watch lectures or whatever. But the alternative would be to post lectures on the YouTube channel, and basically that's what we do in the other seminar. But then those who aren't physically in Moscow will not be able to fully participate. Okay. Are there any more technical things we need to talk about?
Yeah, our Zoom is running out, and I wanted to suggest that I have a limitless Zoom. So if you want to, can go
okay.
there.
Let's. Well, it's a good thing to know. Today, let's use my Zoom because I've posted the link in the math department timetable. So if someone decides to join us, they will be able later, at a later point, possible, unlikely but possible, they will be able to do so. But if we have more Zoom meetings, then indeed it's preferable to not to have any interruptions. Okay. So by the way, when the time runs out, please use the same link.
I'm sorry, I have a question about the topics. Will there be a list of the topics, or we can choose by themselves?
Well, there will be a list of topics, but if you're interested in a topic which is not on the list, then let's talk about it.
Okay, thank you.
Okay. Anything else? Okay. Well, let's begin. So the idea is the homology of several geometric objects, such as the mapping cloud groups, configuration spaces, and both ordered and unordered, and so on, stabilizes as we increase some parameter. Well, just okay. Let me put an eye here. I will explain well, I will explain what this means. Well, let's take SGN. What is it? It's the orientable surface of genus G with compact connected with n boundary components. Well, let's take the diffeomorphism, or more precisely, the group of orientation preserving diffeomorphisms of the surface. Well, let's also take the pi one of pi naught of this group, which is the component group. Well, it turns out the cohomology of this group with Q coefficients does not depend on the number of components for all. Once the genus is sufficiently large, and we'll see later how large is sufficiently large. This condition on the genus does depend on I. But it doesn't depend. It doesn't depend on that. Okay. Now well, let's Okay, let's save the notes. We have 2 minutes left, so I don't want to split the first theorem into 2 parts. So let me just say as an advertisement, in a short while we'll see how to interpret the stable group in terms of the homology of a certain infinite loop space. Now this result is the Madsen-Weiss theorem, and it's basically a prototypical example of the stability phenomena which I mentioned at the beginning. And our goal in this seminar is to understand the Madsen-Weiss theorem in more or less full detail, and then we'll basically consider several variants, generalizations, and so on. Okay, are there any questions? Okay, then let's end this session and use the same link for the next one.